Our next speaker is Ritu from iEngage IT, and I'm thrilled because she's here in the studio with me today. So I'm going to pass over to you, Ritu, and Ritu's going to talk to us about serverless. Okay, thank you.
Thanks. So hello, everyone, and my name is Ritu Bhatt, and I'm going to talk about serverless today. I'm going to talk about serverless architecture and applications, and I may not specifically mean serverless framework. You can check the details of that framework at www.serverless/framework. So what is serverless? Every time this discussion comes up, you will have people saying, oh, there are servers and there is some hardware somewhere. The point of serverless is not that servers are not available. What it means is that the developers and the architects don't need to worry about them. Serverless applications depend heavily on a third-party provider to manage your infrastructure for you. So the serverless applications actually enable the developers and the development team to actually focus on application code without worrying about the infrastructure or provisioning of the servers and managing the networking and real time. Most of the cloud providers today have moved in, are offering the serverless platforms. If we look at some of the major providers, we see that there is AWS Lambda, Azure Functions, Google Functions, and IBM Functions. On the other hand, open source has also come up majorly in the fast space, and we have some of the major ones to name a few like OpenFast, Native, Fission, and Kubeless. Now, moving on to the concept of serverless, if we look at this picture in your architecture and before the serverless, you would have your code and your application inside one container, which would be accessing a database or multiple databases for accessing and retrieving and storing the information. Now, in those cases, the development team was responsible for managing the application, the data, the runtime, as well as the servers, storage, and networking. With the emergence of cloud platforms, if we look at infrastructure as a service, also called as IaaS, in that the team is responsible for managing the application, the data, the runtime, the middleware, and part of operating system. Infrastructure as a service, it offers businesses to be able to access a runtime environment and storage and networking and servers without actually spending on servers right off. So the development team is only responsible for the application and managing of the data, runtime, middleware, and operating system. It also involves you maintaining the versions of your system, the upgradings of your operating system. You can select your own operating system as well as the data. Moving on to the PaaS. Now, PaaS applications, if we look at that, it delivers a framework for developers that they can build upon and use to create customized applications. All the servers, storage, and networking can be managed by the enterprise or a third-party provider, while the developers can maintain the application and the data. PaaS allows businesses to design and create applications that are built into PaaS with special software components. It offers you a platform via the cloud for developers to build their applications. Now, if we go on to the serverless, purely serverless, we can break it down broadly into two categories, which is the BaaS and the FaaS. Now, BaaS, when I say BaaS, I mean backend as a service. So what is a backend as a service? Backend as a service is nothing but it makes it possible to automate tedious coding tasks that are inherent for the functioning of a mobile app or a web application. This reduces the chance of coding error while allowing you to develop higher quality products with a smaller team. Less coding also translates into shorter development time and faster go to the market. With most of the high-tech coding of your app's background pre-built, you will be able to reduce the time of development considerably. If we look at function as a service or FaaS, it allows users to run and manage application code, specifically functions, without having to worry about provisioning or managing servers or worrying about scaling the infrastructure. And importantly, the consumer only pays for the time when they are using that infrastructure. There is no charge when the code is not working or running. Backend as a service, on the other hand, automates and manages the background side of a web or mobile application. It makes it possible to automate tedious tasks like coding tasks. It also offers functionalities like user authentication and user app pooling for you. Like serverless computing, if we look at this picture, we can see that like serverless computing, the platform as a service also offers the need for the developers to build and manage the application backend. However, PaaS doesn't include any pre-built server-side application logic such as push notifications, user authentications, which are part of backend as a service. So in short, we can say that platform as a service offer more flexibility to the developers, whereas backend as a service, it offers more functionality to the users. So we'll just quickly go over a case study of a highly available and secure health tech platform that we created recently. Now, so when we were first approached and we started planning for this health-related app, there were clearly two major areas of requirement for the clients. One was because of the business needs and the market, they wanted to build a very secure and highly available app and bring it to the market very quickly. And second thing, they were expecting a large user base, although there was no data to substantiate that they might have. So there was a possibility that although they were expecting a large user base, they might not have that user base. So for most of us who have been in software development for quite some time, this may not look like a very unique requirement that you want to get it out ASAP. But well, they had the business reasons, and there we were. So after a very quick evaluation of their requirements, we immediately eliminated the workflow, decided to go with mobile backend as a service, MBaaS or BaaS in short. Why we did that? Because that immediately eliminated the workflow for designing the architecture and provisioning the server and the environment for us completely. It also meant that it will be easier to maintain and upgrade that application in future, or maybe in the near future as well. So our next step, once we had finalized that we will go with the MBaaS, was to decide on a provider. For us, it was an easy choice to go with AWS Lambda, reason being that the iEngage IT team had previous experience of working with AWS, and we also have a few guys who are certified in that. So that was an easy choice for us. As well as AWS Lambda also offered everything that we needed as part of our aspirational list that we created as part of creating MBaaS. In AWS, you can actually build a serverless app by using several different AWS services. Now, each service is actually fully managed, and it does not require you to provision or manage the servers. You only need to configure them together and upload your application code to AWS Lambda, which is a serverless computing service. So if we look at that, this was at a high level why we decided to go with Ambas. As you can see, you immediately have the capabilities of having push notifications, social media integration, file storage, as well as the serverless APIs. And it also offered the added advantage of managing the data management and infrastructure for us. So, and now coming on to the architecture, if you look at it, this was a high-level architecture of what we implemented. You can see that the architecture consisted of Amazon API Gateway, AWS Lambda, Amazon Cognito, the Amplify, and the Amazon DynamoDB. If you look at that, the Amplify console actually provides continuous deployment and hosting of the starting content like JavaScripts, HTML pages, CSS, and also the images. So the JavaScript, which was the JavaScript from the browser of the user, would make and receive the data through the API gateway from a deployed using AWS Lambda. The Amazon Cognito user pool helped us with the user management as well as user authentication for the application. And finally, the Amazon DynamoDB, it helped us for having a persistent database layer. So this was a high-level architecture of the implementation of that. If you're still wondering why you need to build a serverless application, well, building a serverless application allows you, in our experience, to focus on your application code instead of managing and operating the infrastructure. You do not have to think about provisioning or configuring servers, since your provider helps you manage that. This reduces your infrastructure management burden and helps you get faster time to market. Now, as I said, there is no server management. It means that there is no need to provision for servers or architect for that. There is no software or runtime to install or maintain or upgrade. Flexible scaling. Your application can be upgraded or downgraded. The components can be changed or toggled, like, say, throughput or even memory. High availability. Serverless applications by default have high availability and fault tolerance built into it. So you don't have to architect those into your application, because the services have that built in by default. The cost, because you don't have to pay for, you only pay for the time that your code is running. There is no idle time cost. So that reduces your cost and reduce go-to-market. Why? Because specifically if I talk about backend as a service or MBaaS, because it offers you server-side business logic as well, like push notifications or user management. You readily reuse that logic and build your application from there. So you don't have to actually code or architect for those repeated functionalities, which are actually inherent for any of the mobile app or web app. You directly get access to that logic, so which directly reduces your go-to-market timeline. In our experience of implementing serverless, it was not always that we only had the advantages. There were obviously challenges, like every technology and every coin. The challenges that we faced were the execution time limitation. Now, if I give you the example of AWS Lambda, it has an execution time limitation of around 15 minutes, but you can overcome that. How? You can actually break down by using step functions and processing logic into multiple steps and combining the ECS task. The Lambda will work as an invocation layer, and actual heavy workload could be handled by ECS tasks, which will be involved only when required. The monitoring and debugging. Again, because we have used AWS Lambda, I'll give you an example from there. The AWS Lambda can only be monitored and debugged using Amazon AWS CloudWatch console and its logs. Now, if your data volume is huge, the debugging becomes a bit challenging in those cases. Now, how do you overcome that? There are some emerging third-party softwares and tools like Dashboard and LowPipe, which provide advanced serverless fast observability and troubleshooting capabilities. The last one is the vendor lock. Yeah, that's a big one. Now, suppose I give you an example that you have used and deployed your application through AWS Lambda, and you are actually benefiting from the push notifications and the user management server-side logic which is offered by it. Now, supposing tomorrow the business decide that they want to migrate away from that onto a, say, new platform like Azure. In that case, you will have to recode and rewrite all of that logic when you are migrating from one vendor to another vendor. To overcome this is very simple. Open source provides a vendor-neutral approach. It provides you a portability across cloud platforms. Not just that, it also allows you to deploy on premises, on laptop, on one cloud or multiple cloud platforms. So the projects where the businesses are not or they don't have a long-term plan of staying with a specific cloud platform, then I would definitely recommend to go the open source way. The demand for faster development and quick deployment of features is rapidly growing. Every day you have clients, every day the businesses, due to the business continuity pressures, they want a faster development and a quicker deployment and as low as possible go-to-market timelines. The applicable need to be scalable and agile by combining serverless functions and other cloud services. Enterprises can build the most powerful web and mobile applications that can scale up or even down based on the demand. To give you some of the examples, Netflix, it utilizes serverless functions to accomplish media content sorting, deploying, publishing, approval, and even for monitoring. And they use connected AWS services over Lambda. The benefits of serverless architectures, as mentioned before, are several, which we have experienced. So these are the benefits. There will be more benefits, but these are the benefits which we have experienced having worked and developed the serverless applications. First one was flexible and adaptive. When I say flexible, it gave us the flexibility to decide on what architecture, how much resources we needed. We could scale up or down based on the demand or based on demand, basically. And agile and faster development. We made use of the readily available server-side logic, which helped us have a very faster development and reduce our development times and rapidly increase the faster go-to-market for us. Separation of concerns, absolutely very important part of it. Why? Because we were only concerned about the application. We didn't have to worry about provisioning or even managing the database or upgrading or any of that. We just needed to concentrate on our code and getting the application at a very good quality. It's highly reusable business logic, highly scalable, low operation and administrative costs because you only pay when your code is running, reduces your cost. It is flexible to choose the development languages, connected cloud services. It is event driven. So you can actually write a function for each and every event, which is which is what the development team really preferred the way forward for it. It provides integrated security. So when we are using fast or function as a service, all we had to do was concentrate on building that function, and we deploy it on the platform, and that's it. We didn't have to architect or design or even provision for any kind of backend or security of it. So in conclusion, I would say, I'll quickly go through it. I'm sorry, I'm running out of time here. Quickly I'll go through this, that if you are planning to modernize an application onto a serverless application, by all means, go for it. And this is a high level. What we would recommend for you is that it's very important to have a look at your whole application as a whole, and then prioritize some of the few functionalities that you want to start with. Take those functionalities, analyze them. Once you have done that, go ahead and analyze some of the other serverless platforms which are available there. Decide on a serverless platform, create a proof of concept, deploy it, and once you have a successful proof of concept, go ahead and migrate the whole of the application and replicate that success into the whole of application. Optimize it, create continuous deployment, CI/CD pipelines to further optimize and reduce your development time. And yeah, if you have any issues, you can always contact me as well. So, and these are my contact details. You can contact me on Twitter or on LinkedIn. And I hope you had a good time. Thanks, Peter, so much. Thank you.